A very warm good morning to everyone present over here. On behalf of MS Swaminathan Research Foundation, I warmly welcome you all to MS 100 webinar series. Today is the webinar 59th, organized as part of the birth century celebration of Professor MS Swaminathan sir. Today's webinar focus on highly relevant and timely topic, that is fisheries advisories, past, present and future perspectives. It is our pleasure to introduce today's distinguished resource person, Dr. Danya M. Lal, who is currently working as a scientist B in Ocean Modeling Applied Research Service Group under the Applied Research and Research to Operation Division at the INCOIS Hyderabad. Ma'am is currently actively involved in strengthening and improving India's marine fishery advisory services. She brings over 9 years of experience across fisheries research, academia, and governance, and has previously worked with institutions such as Department of Fisheries, Government of India, CMLRE, RGCA, MPDA, which give her a broad perspective on fisheries management and advisory system. So we are confident that her insights will provide valuable understanding on the evolution, current status, and future direction of fishery advisory services in India. With this great pleasure, I now invite Dr. Danya M. Lal to kindly deliver a talk. Over to you, ma'am.
Thank you, Abhinaya. I hope I am audible to all.
Yes, ma'am, you are audible. Ma'am.
Okay. So I will share my PPT now. Can you confirm whether it is visible?
Yes, ma'am.
Okay. So, first of all, thank you for MS Swaminathan Research Foundation for inviting us for this webinar series. And it's a privilege for me to present our research progress and future perspectives in fisheries advisories in this webinar. So, I'll be most focusing on what are the previous means past, present, and future perspectives of fishery advisories. So, first of all, regarding the ocean information and how it is needed and what is its significance, as we are aware, like fishermen and those who are involved in the ocean, they are in the ocean of several challenges. So whenever we are comparing a person who is working with the land related activities, the persons or especially the fishermen working in the ocean, they are challenged by several factors, including the vastness of the ocean. There are several uncertainties about the weather, and for their occupational activity like fishing, they have to identify the locations of fishing. Otherwise, they will go around and they will lack the control over the fuel usage and all. So when a person is working in the land, if some uncertainty is happening on a sudden, it will be more easier for him or her to tackle that situation. So the case is not the same for the fishermen. So there comes the importance of information, ocean information. It is like a light in the darkness which guide the stakeholders for more informed decision making, including the safe navigation and fishing, fuel efficient navigation, planned fishing operations, and to tackle with the uncertainties by knowing earlier what are the uncertainties they are going to face. So this is the requirement why we are going for a fishery advisory or a information service. So coming to the core aspect, like what is the fishery advisory? We have to more going into deeper, we have to understand the terminology. So it is nothing but the advisories which are official science-based information and guidance which is issued to the fishers and fishery stakeholders to support safe, efficient, and sustainable fishing activities. And so it is not only advisory which is related to fishery, it is actually involving all those information requirement, which will aid them to reduce the risk at sea, improve catch efficiency, and protect their life and property. So, so it is actually a holistic thing, not only the exclusive fishery warning or fishery information. So exactly that is what INCOIS is doing. So how it is done by INCOIS is it is happening through a stage of processes starting from the observation, which include the satellite-based observation and the buoys or the data observatories, which is distributed over the ocean, as well as in situ observations. So all this observation will go for some sort of research and modeling aspects in our with our team, and it will finally deliver the services which is useful for the society. So here our topic is more related to the fisheries aspect. So these are the major services which is beneficial for the fisheries and which can be subdivided into two, like direct support to the sustainable marine fisheries, and secondly, the sea safety and decision support. That includes the ocean state forecast, multi-hazard, early warning, small vessel advisory services, and all. I'm not going into deeper on this aspect, which was already being covered in some of the webinars in the past. So my focus will be on the direct support to the sustainable marine fishery aspect that include the potential fishing zone advisory, tuna advisory, and HILSA advisories. So we are more going into the deeper aspects of the PFZ. So most of the listeners who are listening to this will be aware of potential fishing zone. So I just want to make you dive some more deeper into what is the basic concepts and how we are actually targeting. Means what are the things which we have to consider while designing or preparing a fishery advisory. So the basic understanding of the fishing ground is inevitable for this. So as you know, like please imagine the ocean, which is very vast, and the dense schools of fishes are within that, and which are not uniformly distributed all over it. So why? Because fishes will require some sort of conditions. So in those areas only they will tend to aggregate. So exactly what is a fishing ground is. Like a fishing ground is a place with a certain area that has a development and utilization value where commercial marine fish or other commercial marine animals are more concentrated, and operations can be carried out by utilizing fishing schools tools. So so the basic requirement is there should be a dense school of fishes, there should be preferred environmental conditions, and there also should be the targeted tools to tackle that resources. If the resources are available in a extreme area or where we cannot reach, we cannot consider that as a fishing ground. So the typical fishery advisory is actually doing the same. It will provide the fishermen with the information on the probable areas where fishes can be able to aggregate. And so this is actually the potential fishing ground, and it can be having various spatial and temporal scales. So example, if you are saying the potential fishing zone advisory, what we are telling about, which is a short-term advisory, like this here, this place, this time, fishes can occur. But there are another dimensions of the fishing grounds also. Like there are some fishing grounds which are permanently fishes are going there, and it is all around the year that will be potential fishing grounds. So there are multiple dimensions of the fishing grounds as well. So to understand more deeply, like how the fishes are distributed and how they will aggregate in some places, just imagine yourself as a part of a fish school. You can see in the figure, like this is a basic cohort. That is a group of animals which is hatched at the same time. So how they will dwell in the oceans. So basically, after hatching itself, the schooling fishes or majority of the commercial pelagic fishes will start its schooling behavior. So after forming the basic juvenile fish group or school, the fast growing individuals will separate into another school because of their fast growing, and just like us, when we grow up, we will select particular persons as our friends. So like that only, the fast growing individuals will separate into some shoals, others slow growing individuals will form another schools, and later on, according to their life history purposes, they again subdivided into temporary shoals for their various purposes. So why they are moving in the shoals? That is because of various aspects. First of First of all, it is for defending against predators. So if it is schooling, it can confuse the predators by making a large globe or something like that. So that can help them defending against predators. Second thing is enhanced foraging success. So if they are moving in the schools, it will be easier to detect the prey. For example, if you lost a small pin or anything in a big room, so you are searching alone and you are calling some more people to search it, means more eyes are looking at a single object will benefit you more, right? So like way, the prey foraging success will be enhanced when they are moving in the school, and also breeding success. Since the animals are moving in groups, the fertilization success and survival rates will also improve. So just like what I mentioned, the animals for their, especially the fishes, they move as schools for different purposes, for breeding, feeding, overwintering, which is not common in tropical waters. And so when they aggregate for these life history purposes, they form different types of grounds. Like for a breeding shoal, when it is aggregating in a place, it will form a breeding ground. For feeding, it will form a feeding ground, and for overwintering purposes, it will form overwintering ground. So for advisory perspective, like a person who is interested in the fishing ground prediction, the most focus will be on the feeding ground. Why? Because we have to think about the sustainability of the fishery also. Like it is more right, or it is more proper to locate the feeding grounds and proceed for the identification of the potential fishing grounds. So, as I told, majority of the major fishing grounds are located in the areas where major feeding grounds are formed. So, what are the peculiarities of this area? These areas should have sufficient salts, primary production, and abundant food organisms. And in the global scenario, if we look into, the majority of the high productive zones or the feeding grounds that can turn into the potential fishing grounds are located along the upwelling area, then current boundaries, then eddy areas, and continental fishing grounds, as well as the reef banks. So why? Because these areas have more productivity, more nutrient availability, and chances of aggregation of fishes are more. So as I have previously said, there is no a single scale or dimension of fishery prediction. Fishery prediction can be of multiple scales. If we consider the global scenario, the fishery prediction can be yearly prediction of fishes for a decade or a year. Suppose the last 10 years, the global fish production was this much tons. Considering the present level of exploitation level and all, this might be the next 5 years global fish production. So that is also a type of fishery prediction. But that is having a coarse resolution that is for an entire year. So for regional scale, if we are saying, it is more subdivided into a particular region, like Northern Indian Ocean, if we are considering. So what is the availability of fish stocks in the coming years with respect to the recruitment dynamics in the previous year? So those type of predictions are regional scale prediction. So also, as I have informed like conventional fishing grounds. So these are some we already know some of the areas which are conventionally known as ideal for fishing all around the year. So they are also a type of regional scale fishery prediction. Coming to the event scale, that is, event scale means very finer resolution in terms of time and space. That is short to real-time predictions that include potential fishing grounds. So potential fishing grounds are actually a example of the finer and event scale fishery prediction. So we just discussed about what are the principles of identify fishing grounds. That is based on the feeding ecology and all those things. So how the concept of this was evolved over the decades. So as we know that fishing is not a occupation or a what it was originated sometime recently. It was happening since time immemorial. Okay, so the ancient people itself, they started fishing from the shores and banks for their subsistence. So they've usually fished in the intertidal zones and shores in the vicinity of the islands. So later down the year evolution, what happened? The people they are continuously fishing and they started realizing the patterns like what is the density of various schools with respect to some season, some places, or change in the wind patterns. Those type of perceived information or understanding they receive, and that become the fundamental thing to develop the concepts of the fishing ground. So later on, due to the emergence of the advanced fishing technology, oceanography, and remote sensing, now we are able to predict the daily scale availability of probability of the fishing zones itself. So that way, the concepts of fishing ground and its prediction and the fishery advisory services have evolved over the decades or centuries. So now we will see how potential fishing zones are actually identified. What are the scientific things which is involved in this? So as I told, so we have already discussed about the things like we are basically focusing on the principles of identification of feeding grounds where the fishes tend to aggregate. So that's the core aspects of fish PFZs. So then how to identify where the fishes will be where the feeding grounds will be, how it can be located. So we have to identify some proxies which can be identified remotely. So remote sensing will enable us to identify these proxies and mainly the SST gradients. And later on, chlorophyll was added to that. They were considered to be the proxies for the feeding grounds and thereby the potential fishing zones. So the thermal sensors were initially used, satellite thermal sensors that can able to detect the surface skin temperature only. That is the very surface level temperature only the thermal sensors can sense, and they couldn't explain the subsurface productivity and all. So that's why later on the chlorophyll sensors information was also included into the potential fishing zone delineation. So why? Because the ocean color sensors, that is the chlorophyll sensors, can detect signals from below the surface due to the greater penetration of the visible radiation as well. So a combination of the thermal and chlorophyll signals were used for deriving the potential fishing zones. So just to make you understand, what I have already discussed about the thermal fronts, like the PFZs are identified based on the thermal gradients I mentioned. So to understand more, you can see the picture. This is actually a thermal front zone. That is the surface discontinuity at the intersection of two water masses or water systems or oceans currents with significantly different properties. So that is called a boundary or a ocean front. So why? Because this area will be marked by the confluence of either two water masses or either it by an upwelling. So there will be a gradient. So why the gradient is supposed to have more productivity means usually this two gradient or two water mass boundary will be having the aggregation of the plankton from both the sides. like from a colder waters also, warmer waters also. So the richness of the planktonic organisms will be more, and that will, and also other physicochemical parameters also will be unique. So there will be a tendency of the fishes to aggregate to these areas, and also especially towards the cooler part when it is a thermal gradient. So usually oceanic fronts are considered to be good fishing grounds when they are formed. So even friends, if we are considering also, there are multiple, this itself is a big subject like ocean fronts, and it can be of various dimensions. Like for example, the length of the front, some of the fronts will vary from several hundred meters to thousands of kilometers. Coming to the width, if we consider, they can be of the horizontal width, it can be of 100 meters to 50 to 200 kilometers of width. Then vertical extent to in the depth, if we are seeing, it can be several hundred meters to as deep as 2000 meters. Span also, some are short-lived, and some are quasi-stationary, and some are seasonally persistent. Some fronts will be persistent all over the year also. So physicochemical properties, if we consider, they can be vary from 10 to 15 degrees Celsius and 2 to 3 ppt, but the very common is less than 5 degrees Celsius between the two water masses and 1 ppt. So there is a work by Belkin et al. He have explained the type of thermal fronts which is forming around the major large marine ecosystems of the world. So these red colors are indicating those from the Arabian Sea and Bay of Bengal. If you can see, the Arabian Sea, majority of these forms are U type. U means upwelling type fronts. So the upwelling phenomenon is the major contributor for the thermal front formation in the Arabian Sea. Whereas the Bay of Bengal, if we consider F type of fronts are formed. F means the freshwater confluence fronts. So, like we saw, why I am telling all this is to link you with the PFZ. So, first we described about the feeding preferences, and feeding preferences or feeding grounds will be more concentrated on the frontal zones, and that's why the focus of the PFZ identification will be on this. So, for Arabian Sea, the frontal identification is based on the upwelling, and the Bay of Bengal, it will be based on the freshwater confluence. So this is the process which is happening for the identification of PFZ. So first, as we already discussed, SST and chlorophyll imageries are inevitable for that. So this, how it will work means, when a front is detected, there is a gradient of temperature is observed, and there is a high concentration of chlorophyll is observed. That area is usually designated as a potential fishing zone. And this was initially, it was like that only the chlorophyll high concentration and thermal front presence. But later on, considering that the oceanic features may shift by the fishermen reaches there, the wind vectors are also incorporated. So these wind vectors will be useful. When the fisherman is going to that location, and he can travel in the direction of the current also a little bit, so that he will not miss the potential fishing zone when the duration matters, when they receive the information and they reach the PFZ location. So this is the overview of the PFZ advisory. So as I told, the multi-satellite data products will be used, and this will be processed for the front detection and chlorophyll high concentration identification, and the advisories will be generated. So the advisories will be generated for multiple sectors like Gujarat, Maharashtra, Karnataka, Goa, Kerala, South and North Tamil Nadu, South and North Andhra Pradesh, Odisha, West Bengal, Andaman, Nicobar, and Lakshadweep. So these are the major sectors. So it will be delivered in terms of potential fishing zone maps as well as tables. So this map, you can see the dark colors in the boundary of the India is indicating each of the landing centers. So the information which is provided through PFZ advisory will have that the most closest PFZ location from each of these landing center. You can see like this latitude and longitude is indicating the Mongol, that landing center, what is the nearest PFZ in that particular day, along with the distance from that landing center to that particular location, as well as the bearing, which angle they have to move from that particular landing center to reach that. So this is the text information. Likewise, map information will be also available for each of these sectors. So, and then the generated information will be disseminated to the fishermen. So this is not only we are routinely doing this dissemination processes, it is actually validated in the field also by the coordination, with the active coordination with the stakeholders in the field. So this is a PFZ validation experiment which was conducted in the off Mangalore coast during 24 December. So likewise, we will understand what are our limitations, and we are trying to rectify the time delays and trying to improve the advisories. So as I told, the ground level support is very much important for us for being in Hyderabad and communicating with the fishermen. So MSSRF INCOI's partnership was very crucial to establish the linkages with the fishermen all over the coast, especially in the coast of Tamil Nadu. And presently, we are having a network, or we are disseminating information to over 1 million user base. And the MSSRF's contribution is highly remarkable in that. And still, the collaboration is going on. So that's up to the present scenario. Like the PFZ identification, I hope you understood that it is based on the feeding ground detection and the front detection. So what next? How to move forward into more complicated things and intricacies of the fishery prediction. So as we continuously interact with the fishermen, the demand for the fishermen is to give more species-specific advisory. That is not only the location where fishes are available, what are the species which also be available in that locations. So to understand all those things, we require another set of knowledge on the life cycle of the species, the movement patterns, their tolerance limit, areas with ideal environmental condition for a particular species of concern, then the fishing conditions and the pattern of change over time. So that is not so easy to transitioning from a normal PFZ into a species-specific PFZ. So many things need to be considered. But we have initiated, or we have in past itself, we have started the attempts focusing on this. So the most important thing to consider while we are transitioning from PFZ to species-specific PFZ is to understand the threshold or the optimal ranges. So this is a simple thing, diagram indicating a bell-shaped curve of tolerance. So in the x-axis, it is showing the value of the parameter, which may be temperature, salinity, current velocity, or anything. And y-axis is showing the population. So it is evident that the population density will be higher for any species. You consider sardine, mackerel, or anything. So density will be higher in a particular optimum range indicated by this peak. So below that range also, the species will be either absent or low population, and above that range also, there will be low population or species will be absent. So the core idea of developing species-specific advisory is to understand this optimal range for each of the major environmental parameter. To understand this more in a more better way, I am giving an example of Pacific chub mackerel. Their relationship with this environmental parameter, which is reported by Chen in 2022. You can see that Pacific chub mackerel in the China coast, that their abundance is drastically changing with the temperature ranges. So you can see that when the shore temperature is 13 to 16 degrees Celsius, the animal or the fishes are indicating the beginning of their spawning. So when the temperature rises to 17 to 19 degrees Celsius, the dense shoals of spent animal, that is the breeding is almost over, and the shoal is mainly composed of the spent animal. And when the temperature further rise to 22 to 23 degrees Celsius, the animals are disappearing into the deep sea. So this particular example is showing very important insights for a fishery prediction perspective. First one is how the smaller changes in the temperature preferences are impacting their life history and how it is linked with their life history. Secondly, how this temperature impact on life history can be linked with the fishery catches. Like we can see like the middle range of temperature having more number of spent shoals. So that will be a peak time for the catches to maintain sustainability. So like way for all organisms, if we could able to see the time, the temperature preferences with respect to life history, it will be more good to predict those species abundance sustainably. So unfortunately for the Indian waters, if you can see Indian mackerel, which is also a related species, same family of this Pacific chub mackerel, but it is staying in a tropical context. Tropical context, delineation of this ranges will be very tricky, and they started an initiative, Fish app, which is actually an Android app, which can be installed in the fishermen's mobiles in multilingual forms. So and we are collaborating with various collaborators in the along the coastline, and using the user interaction training workshop, these apps are installed in the fishermen's mobiles. So you can see here like it is very simple, and when the fisherman or the user opens the app, there is an option for the capture of the images. So when the images are captured, along with the latitude and longitude, it will directly come to our server. So as many as fishermen are using the service, as many images we will receive. So after the receipt of the images directly in the server, we will do the images will come with the latitude and longitude. Image segregation will be done, and it can be coupled with satellite and model in situ environmental data, and will be used for species-specific habitat suitability modeling. So like this way, we are proceeding now. So these are some of the images from the field, how we are interacted with the fishermen over demonstrating this app. And these are some of the images which we are received through the same. So you can see how useful and how effective it will be if it can be accelerated in a big way, how it will be supportive for the INCOIS missions. So another aspects, futuristic aspects we are working on is front to fish. Like as we know, our current understanding is limited up to just understanding the feeding grounds. So what is making the feeding grounds more productive? So going into a deeper aspects, this approach will work. So this involved the understanding of the SST, chlorophyll, the frontal detection, and we will see what is the time series changes happening in these frontal areas using in situ observation, nutrient biogeochemistry, food and feeding of fish. So as you know, some fronts will be persistent over several times, some will be short-lived. So for the persistent fronts, how the food chain is progressing day by day in that. So all those aspects will be studied in this program, and that will yield in the prediction of species also, more accurate duration and persistence, prediction of yield also. So it is a futuristic program, for improving the fishery advisory. Another thing is majority of our potential fishing zones are from the coastal zones. And also as we know, the sustainability of coastal fisheries is challenged. We need to go more deeper and also beyond the exclusive economic zone also to harness in a economic blue economy point of view. So we are planning on means exploring deep sea potential fishing zone by devising experimental deep sea PFZ, in situ validation and support to expand the deep sea fishing industry to boost the sustainable blue economy. So these are the proposed sampling locations for conducting this type of uh, deep sea potential fishing zone validation. So several type of data source we are anticipating to use in this, including satellite, Argo, glider, eDNA, buoy-based information, fish app, the government agencies, NGO partners, all will be a part of this program. So mariculture and seaweed farming also a area for of interest, because as we know, the sustainability of resources are challenging. We need to see for the alternate options as well. So INCO has already attempted the possibility of mariculture site selection using various parameters and identified some of the potential locations also. So more studies are required on this, and also in the future mariculture farms, if it is established, INCO is planning to provide customized services for those mariculture farms as well. And some of you will be aware, like ISRO has started a monitoring program for the fishing vessels, AAS-based tracking of all the fishing vessels, and the process has been started by installing the transponders in the fishermen's boats. And INCOIS will act as the data center for this AIS-based information. Means INCOIS will be able to track the movement of the fishing vessels. All this data depository will be vested with us. So this is anticipated to enable continuous monitoring of fishing activity, real-time dissemination of the ocean information services, and some sort of AML data analytics for the surveillance, and to see which areas are more unsustainably fishing, which are the crowded area. All those things we will be able to analyze with this initiative. So these are the current fisheries and ecological services. The research is progressing in various dimensions for species-specific PFZ advisory, probabilistic PFZ, what probability the fishes can be there in a particular PFZ, and front to fish, which I have explained. But still there are several data gaps. We need more comprehensive data sets on the fishery catches. Active collaboration is required. So these are the major challenges. So coming to the way forward, which I have already mentioned, but these are a comprehensive summary of what the future of the fishery advisories are. So presently we have only PFZ, so we will be more focusing on species-specific advisory, species for several species of importance, decision support to deep sea fishing, that is also anticipated thing. Then another thing, fish stock prediction for commercially important groups. Means everywhere we are telling about PFZ, go and fish there. So that may be questioned in the future for the sustainability. So sustainable yield predictions are also a futuristic view of the fishery advisories. Then ecosystem-based productivity mapping and predictions, yield prediction from various ecosystems like corals, mangroves and all, modeling contributions to productivity, recruitment and ecosystem services. These are one of the priority area. Then prediction of endangered species occurrences. So which are the areas where marine mammals, turtles, etc. will aggregate, so that that area can be avoided seasonally or partially from the fishing activity. Then decision support to mariculture, as I already told. Mariculture site suitability is the initial point. Later on, if in future more coastal and seaweed and cage farms, offshore cage farms are established, they require customized services for water quality, current, all those things. So these are the anticipated fishery advisories. So the scientific pillars for which obviously the advanced observations, in situ experiments, habitat suitability modeling, and integration with more other models. So as a summary, we have some existing services and we have anticipated services as well. But all these improvements require advanced observations, improved sensors, multi-institutional collaboration, data sharing, mutual sharing of expertise and technology. So that's the end of the presentation. Thank you for your listening. If you have any queries, you can just let me know.
Thank you very much for a detailed presentation. It is very
Thanks,
useful for all the persons. But whenever we went to field, the fishermen asking the basic queries. I just what they are asking, the fishermen are catching the more fishes, but it is not reflected our PFZ data. If you have any specific reasons, already you said the thermal and chlorophyll is determining this factor, but the fishermen again asking. That's why I'm asking if you have any specific reason. We would like to know.
Okay, sir. So basically, we are identifying PFZ based on SST and chlorophyll, as I mentioned. But the thing is that all the SST fronts and chlorophyll peaks, which we are identifying in a day, will not be disseminated at, say, PFZ, because that will cause a problem for the sustainability. So means a certain percentage of the identified locations will only be disseminated as PFZ. That is one reason. So another reason is like, as you know, like fishermen has their own understanding and knowledge. So that may not be correctly reflected in the SST and chlorophyll information only. So there may be other parameters also that is contributing to the fish availability. So we have yet to explore that information also to be included with the PFZ, so that we can improve the PFZs based on the traditional fisherman knowledge also. Is it clear, sir?
Actually, they are detecting the fishes due to the color, the
Okay.
marine color only. They are determining the fish catch. They locally they said cripe water like this. If you the brown algae is available now, they said cripe water like this. So many traditional knowledge is there, but we have to incorporate that marine color and other thermal region. It will be suitable for in future.
Definitely, sir. This is very valuable comment, sir. We will consider that, sir.
Yeah. Ma'am, another one query is actually you already explained that, but now only we are disseminating the species specific data on tuna and hilsa. But the small scale fishers are asking the oil sardine, and sealfish and mackerel and everything. But now only we are doing some research based fish app. The fishermen also the uploading some images. So when we get that small fishes like pelagic fishes, oil sardine, sealfish and mackerel.
Okay, sir. So, as I have mentioned in my PPT, there is a huge limitation for us to delineate the species-specific preferences for the tropical species, like our sardine, mackerel, and all. So that require more and more data sets, sir. So we are trying to collect the catch data, means which location-specific catch data as much as possible. So as more and more data comes, then only we can able to refine our predictions. So if we are giving any false prediction, that will be more worse than benefit. So as of now, I cannot tell like when it will be ready, But definitely we are on the process of actively on the process of developing more accurate prediction for this small scale fisheries also. So hopefully in some coming years we will be able to give such predictions with a definite level of accuracy.
Thank you, ma'am. All the small scale fishers are waiting for this data.
Okay, sir. Sure, sir. We are working on that, sir.
Yes.
Yeah.
Good afternoon, madam.
Hello, sir.
Madam, are you hearing my voice?
Sure, sir. I'm hearing you.
Well, actually, the fish app is only for APK file. So it's not in Play Store app. Some of the fishermen installed the APK file. Some issues in their mobile phone. So it will possible for update the fish app in Play Store in future.
Okay, sir. Actually, we initially the fish app was means launched in the means Play Store only. But due to this, since it is tracking the location, the it was rejected by the Play Store. So we are actually that's why we are presently operating with the APK. So definitely we will try to means proceed in the proper channel to means display that or disseminate that app through the Google Play Store, sir. But there are some challenges, so we are trying to address that.
Okay, thank you.
Yeah. Any more doubts?
Actually, now we are providing the PFs data, the soulfish data. We are disseminating through WhatsApp, WhatsApp or Inca is open source. We are providing the PDF format. If you have any possibilities to give the tuna forecast, like this net is useful for the fishers, but now only who are having mail ID and password, that person only get the detail. If you select, we have to select any 10 fishermen. If you provide to them, it is very useful to tracking them. We are getting the feedback very easily.
Okay, sir. Oh, understood, sir. I will discuss this with our team and I will let you know, sir.
Okay.
Okay.
And then finally, you said one interesting one, the fish vessel monitoring. Now Inca is doing that activities.
Sir, it is actually the installation of transponders have started. The center for monitoring this is yet to be installed here. So within some 2 years or so, it will be established. So after that, we will be able to monitor that.
But now there are so many mechanized fishers, they are having one app, where is my vessel? They are purchased from in the private sector. They are tracking their vessels in Kerala or Tamil Nadu, wherever it is. So that I'm asking, because we are Inca is having on Sarat and fish vessels monitoring is both are different.
Yes, sir. That those are different, sir. Sarat is for missing objects, sir.
Yes.
Means whatever is missing, any object is missing, what is the probability of that object to be transported through the ocean? And Incois currently doesn't doing any tracking of this AIS based tracking, but this is formally this program is launched and the initial setup is going on, sir. And after that only we will be able to means work as a center for this monitoring of the vessel movements.
Thank you, ma'am. Thank you very much for your detailed presentation and addressing the queries.
Thank you, sir. Thank you. So can we log out?
If you no more question, if any more question, please. Otherwise, if no more question, we go for vote of thanks.
Okay.
One money, Abhinaya,
Yes, sir.
please give official vote of thanks.
Yes, sir. So, on behalf of MS Swaminathan Research Foundation, I extend our sincere and heartfelt thanks to Dr. Danya M. Lal for delivering a highly insightful and informative talk on fishery advisories past, present, and future perspectives. Ma'am, your presentation was clearly highlighted the evolution of fishery advisory services and the critical role of ocean modeling, applied research, and science to service approaches in supporting sustainable fisheries and fishing communities. We truly appreciate you for sharing your valuable knowledge and experience with us today, ma'am. And also, we extend our sincere thanks to the MSSRF organizing team, coordinators, and technical support staff for their dedicated efforts in successfully organizing this webinar. And I also extend my sincere thanks and appreciation to all the participants for their enthusiastic engagement and thoughtful questions, which enriched today's discussion. So, once again, thank you all for your valuable time and participation. Thank you, Numa.
Thank you so much, MSSRF, for this opportunity. Thank you.